Hey, welcome back. This is part 2 for our online Pendulum lab. And so here I'm going to show you some video data, and you're going to use that as a basis for analysis of what's going on. And so if you haven't seen part 1 of this series, I'm going to put a link in the upper right about now. And I think you should watch that first. But if you're just jumping in, I want to let you know a few things before you start looking at some videos here. So first of all, I had asked you, what factors do you think affect the period of a pendulum? What factor or factors, if any? And typically when I ask students this, after a while they come up with 3 or 4 different ideas. So here are the common answers. Let's see if you came up with one of these common answers. So first of all, the mass of the bob. A lot of students think that, hey, if we change the mass or the weight of the bob, then that will change the period of a pendulum, which is a very good thing to test. So we're going to go about testing that with my data and see if there's an effect. Secondly, students typically come up with the length of the string. If they change the length of the string, does that change the period of a pendulum? Definitely something worth looking at as well. And lastly, the angle of release. So this angle right here, essentially, if we change that, like if I were to release it from back here, would that change the period of a pendulum and so on? That's something that's worth looking at. And lastly, sometimes I get how much it's pushed up or down on release, which usually in a class I'll get 1 or 2 students who want to do something like that. My response is typically, what would be the problem with testing that? Well, the problem with testing that is you're going to have to get a measurement of whatever that push is, whatever that force is, up or down, and that's going to be really complex and really hard to do, nearly impossible. So let's forget about that one for now and look at data for these 3 options right here, and then you're going to do the analysis, and if you're in my class, you're going to draw graphs for these sets of data as well. So let's go ahead and get to it. One thing I want to mention before we begin, so I just grabbed some random washers in my classroom. So I do have different masses here, and I've written them into the background of the videos that you're going to see, the amount of mass and the length of the string and so on that we're dealing with. I also want to point out that I do have a digital scale. These things are very precise. It's down to the tenths of a gram, so we don't need to worry about precision for the mass, so to speak. So that should tell you something when we're thinking about error. That should give you a clue of something to consider. And one more thing before we start getting into data, I've superimposed a right triangle here, and so I've got a distance here. This is always going to be 57 centimeters from the height up here. You can't actually see the very top of this in this picture right here, but from the top of this down to where I'm going to measure from. Now, I'm not saying it's the length of the string. This would be the length of the string right here. This is the length of the string, but note, I want to get a right triangle going right here. So I'm going to pick a horizontal line that's easy to use, and that horizontal line that's easy to use is right along this meter stick right here, and I'm going to say, all right, well, every time I'm going to measure 15 centimeters out from this middle axis point that you'll be able to see in the video. And so I try to release it exactly at 15 centimeters every single time, unless I note otherwise. In this case, for instance, in the background, you can see it's 10 centimeters. So here I'm pulling it out 10 centimeters. As opposed to 15 centimeters. Now with that, you can go about solving for this angle right here. We don't have a protractor, but actually we'll get better data if we use a little bit of trig to be able to solve for this angle right here using an inverse trig function, like inverse sine or inverse tangent or something. If you don't know how to do that, I'll put a link up for a screencast most likely, but I want you to try it, especially if you're in my class. I want you to try and see if you can figure out how to do that first, or work with your group mates first to see if you can figure out how do you solve for this angle here. If I know this leg of the triangle, this leg of the triangle, how can I go about solving for this angle? Alright, so let's go ahead. We're going to look at 3 videos here in succession that have to do with varying the mass. That means changing the mass, and I'm going to try to control for the other variables. So the question I have, what should we do with the length of the string and the angle of release? And the answer is we should keep the length of the string and the angle of release the same. Why do you think that is? I did put a screencast up earlier that talked about controlled experiments, so you can make reference to that, or maybe I can put a link down below. But we're going to vary the mass and keep the length of the string and the angle of release the same, primarily so that we know that our result is based on the mass, not based on some combination of 2 or 3 factors. Alright, so let's go ahead and take a look. By the way, I do slow this down, so for every one of these videos you're going to see in real time what it looks like at first, and then right after that you're going to see a slower version. It's 5 times slower than what it was before. Alright, so you saw those videos, and hopefully you can get data from that video evidence. Now let's take a look if we were going to vary the length. What data would we get about how that would affect the period of a pendulum, and what would we do with the mass of the bob and the angle of release? Okay, and lastly, we're going to vary the angle of release, and I'm going to do that by changing the width at the bottom of the previous triangle that I showed you. I believe it's 10 centimeters, 15 centimeters, and 20 centimeters is going to be the width of that triangle, although the height of the triangle is going to stay the same. Now that's going to change that angle, right? So you're going to have to do 3 of those calculations to solve for the angle that's involved. All right, let's go ahead and take a look at that video. All right, and now that you've looked at the data, I want to talk about how you're going to finish this lab up. So first of all, you're going to make data tables with units, and you're going to make 3 good-sized graphs that fill up most of the graph paper you have available. So if you have like 1/2 sheet, work with that, and don't draw a super small graph. They're too hard to read, and graph scaling is an important skill to be able to use. Unfortunately for this lab, we only have 3 data points for each of the factors that we're looking at, which is less than I would ask or require if we were in person. It's a lot easier to do this in person than to take video of this. Normally I would want 5 data points, and then that would give you a more clear trend. So I do want you to draw a general best fit line, and you're going to look for a basic trend. So basically the question is this generally a positively sloped relationship, a negatively sloped relationship, or generally does it have a slope of nearly 0? And I want you to think about, well, what would it mean if you had any of those 3 logical options? Like if your slope is positive or negative or roughly 0, what does that mean for those 2 factors and how they affect each other? In this lab, it's really important that you get the independent and dependent variables correct. Every time I run this lab, I will have some students get this incorrect. So in the x-axis, you've got your independent variable. In your y-axis, you've got your dependent variable. So think about what is dependent on what, if it helps put it into a sentence, and see what makes more sense. So for instance, would this sentence make sense? Option 1 would be, the mass of the bob depends on the period of the pendulum. Or option 2 would be, the period of the pendulum depends on the mass of the bob. Which option makes more sense to test? So think about that. Okay, and lastly, you're going to draw your conclusion based on your data, revisit your hypothesis, figure out if it was right or not. It's okay to be wrong in a hypothesis, as long as what you're saying is based on the data. So in any case, this is our online lab, so hopefully that was helpful. It's definitely new for me. If you have any comments down below, please let us know, and I hope you all have a great day. Also, I've got a lot more screencasts in this unit, and I'm planning screencasts for the entire year of physics, so please stick around for that as well, and take a look at my channel. Take care, have a great day, everyone.